Now we'll discuss the static zero hazard and static zero hazard cover. Now first we'll discuss the static zero hazard. Now to understand the static zero hazard, we take an example of an AND gate where one of the input is A, another input is complement of A. In this case, the output Y always will be equal to 0. Now let us take a particular case where there is a transition takes place for input A from 0 to 1. Now when it was 0, when A was equal to 0, that complement of A was equal to 1 before. Now A has become 1, immediately it is the one of the input has become 1, but the complement of A do not become 0 immediately because of the delay in the NOT gate. As a result, the output becomes 1 for a small duration of time because of the delay in the NOT gate. And that is been explained in this graph. Here you can see the input A is changes from 0 to 1. And the complement of A do not become 0 immediately. It takes some time, a period of time T1, and it becomes 0. And during this period of T1 time, you can see both the input A and the complement of A becomes 1. Therefore, in this circuit, for a small period of time, the output becomes 1. And that is reflected into the output Y. This is the graph of output Y. And another thing to be here, this is the, you can see, this is the always it is 0 output Y, and but for a smaller duration of time T1, output becomes 1. But another thing, due to the delay in the AND gate, that also not reflected in the output immediately. It should have been reflected if there is no delay, but this reflected after a period of time T2. It has been reflected in the output. And therefore, T1 is the NOT gate delay and T2 is the AND gate delay. And this is the static zero hazard. Let us discuss the static zero hazard cover. That means how to make a particular circuit free of static zero hazard. Now to understand that, let us take the expression in the max term forms, and we simplified the Boolean expressions and we got the minimized form in the POS form, product of sum forms, and we have drawn the circuit, and that circuit is not free from static zero hazard. That we discuss now, how it is there is a static hazard is present here. Now to understand that, let us take a particular scenario when A equal to 0, B equal to 0, and C is also equal to 0. In that case, you can see that B equal to 0, C equal to 0, therefore output is 0. But in the upper that OR gate, and that A equal to 0, complement of C is 1. And therefore output is 1, but due to that AND gate, ultimately this is 1, this is 0, therefore output is equal to 0. Now let us take a particular scenario when A equal to remain to be 0, B remain to be 0, and C makes a transition from 0 to 1. As a result, the C will become 1 and the complement of C should become 0. Now let us it should become 0. Now let us see what happens. Now as C takes a transition from 0 to 1, this is become 1 immediately. This C becomes 1 immediately. C becomes 1 immediately, but the complement of C do not become 0 immediately. It remains to be 1. Therefore, both C also is 1, and the complement of C, which is the one of the input to the OR gate to the gate number 1, I can say gate number 1, then it's also become 1. Therefore, output of that, due to that period of time, due to the delay in the NOT gate, that period of time, it remains to be 1. And because C is also 1, that is also it becomes 1. And therefore, you can see that both the input to the AND gate is 1 for a small duration of time because of the delay in the NOT gate, and the output becomes 1 for a small duration of time. And that is, we can tell, this is the static hazard 0 is present here. Now let us take the same Carnot map. You can see that one of the group is being added here, and that is due to that addition of the group, another gate to be added, A plus B is a gate to be added. Remaining things are same, and because of that, we can show that this circuit is free from the static 0 hazard, because now we can explain why it has become free from. In the previous case, you can see that because of the delay in the NOT gate, both you can see both that is this gate number 1 or gate number 1 output was 1 for a small duration of time, and that gate also BC, that gate also it was 1 because C has transition of from 0 to 1 takes place. But you can see the gate number 2, which is the newly added gate, it will remain to be a 0 because A and B do not change because A is 0 and B is also 0, and therefore the output of that gate number 2 is 0. Because of that, output remains to be 0, and therefore we can say this circuit is a free from static 0 hazard.